Today, I'm going to be explaining different forces in a pendulum and how different variables affect these forces. Let's start with the first video. Let's start out with the basics. A pendulum is a swing-like feature that is used in various things like clocks. When we push a swing back, it goes up and down repeatedly around the center position of where it sits. This is known as the oscillatory motion. What do you think might affect the speed and motion of the swing? The weight on the object of it? The length of the support? Well, I'm here to help you understand more about these cool machines. Let's take this first video for example. I'm using the weight of one bead as my starting point. Some might think the weight of the object swinging right might have an effect on the motion of the pendulum. This is not the case, however. The mass on a pendulum does not affect the swing because force and mass are proportional, and when the mass increases, so does the force. A force is just a push or pull upon an object, resulting from the object's interaction with another object. When we watch this second video, notice how the more mass I put on the string doesn't affect the motion of the pendulum. Another way you can alter the motion of a pendulum is through the length. The length of the string affects the pendulum's period because the longer the length of the string, the longer the pendulum's period. This makes the pendulum with the longer string complete less back and forth cycles in a given amount of time because each cycle takes more time. A way you can measure this is by using a stopwatch and recording the period, the amount of time it takes for one swinging back, to show that mass doesn't affect it, but length does. As we watch the next video, watch how the length affects it. As we can see, the different variables such as mass and length have great effects on the pendulum's oscillatory behavior. Before I move on, let's define some more terms. Displacement is the amount of space moved away from the starting point. Suppose I ran a mile west. I would have a displacement of 1 mile. But if I run back to my starting position 1 mile east, I would have a displacement of 0. This leads me on to my next topic of restoring forces. A restoring force is one acting against the displacement of the pendulum and trying to bring the swing back to its original position. An example of this restoring force is right in the pendulum. The spring attached to the top continues to try and bring it back to the center point when moved. Pay attention to the spring at the top in this next video. Finally, let's talk about the internal energy that's being built up during these periods of the pendulum. Potential energy is basically the stored energy an object has because of its position or state. Kinetic energy is basically the energy an object has due to its motion. At the bottom of the pendulum, there's no potential or kinetic energy. Ways we can find out these values is using the initial displacement of the end of the spring and their storing force. We can apply these values in everyday items such as grandfather clocks and swings. Thank you for listening to my presentation about simple harmonic motion, and have a good day.